So we have a lot to cover today. So I'm going to go through the introduction of the concepts of the Azure Responsible AI in the first 15 to 20 minutes. Then I don't know about you, but I like to see things demoed and see how you can actually apply it to real life situations. So that would be the second half of the webinar today. So to get started is, as you guys know, AI is part of our lives. It consumes everything we do, both on an individual level and also on a societal level. Businesses, whether you're in finance, healthcare, or education, across different industries, companies are also infusing AI in their solution. So the exciting thing is AI innovation is rapidly growing as we speak. Um, uh, like I mentioned, businesses are frantically trying to adapt AI into their processes or products to be able to have a competitive edge in the market. Then another thing is, as all these breakthroughs and innovations are coming out in terms of AI, the societal expectation is also evolving as a result. And another implication of AI constantly increasing is governments are now seeing a need to regulate AI. So that's where AI, the state of AI is right now. So we talked about societal expectation increasing. As you guys know, on a weekly or daily basis, we constantly see headlines about AI. And some of it is very positive, but some of it, there's scrutiny in terms of what AI is doing and some of the limitations that or areas that it falls short. So this is very important, and it's something that affects all of us, especially if you're in the machine learning professional space. So I'm sure you guys are wondering, okay, why responsible AI? We hear about responsible AI all the time, but why do we need it? So one of the areas of that responsible AI is much needed is we are seeing systems where they continue to miss expectations. These are AI systems that are deployed out there that will see that, okay, for this AI solution, it missed expectation. Another area is with these breakthroughs exposes blind spots or exposes new issues that we never really considered. Then finally, kind of like how I mentioned, the government and also not just government, but the different industries, depending on the industry that you're in, they're auditing and also regulating how we develop and deploy responsible AI. So those are some of the reasons why responsible AI is important. So one of the things that Microsoft started back in 2018 was to come up with guidelines and principles that our customers can use and also developers can use. And these are best practices around fairness. So fairness is for example, is being able to have an AI model that is fair across different groups. So it's not favorable or discriminatory to other groups, especially when it has to do with gender, race, or age. Then another area is reliability. Reliability is pretty much everybody that implements an AI solution. When you put it out there, is it trustworthy? That sort of thing. Is it going to cause potential harm? Another area is around security and privacy, and that's another entity that there's heavy scrutiny around. So as we innovate in AI, security is a very important thing that we need to take into consideration. Inclusiveness kind of goes hand in hand when it comes to sometimes bleeds into the fairness side of things. But an example that I can think of for inclusiveness is there are about 1 billion individuals around the world, and they all, or I'll say we all have disabilities. So when implementing AI solutions, it's very important to be mindful of people with disabilities. Some may be obvious and some may not be obvious. So trying to think of ways to be inclusive. Then there's transparency in AI now. You have to be able to show why your model is behaving a certain way, be able to explain when, why, what is driving the model's behavior. The accountability. When you're looking at the AI model, how can we make sure it is doing what we need it to do? And also, how can we be forthright to the general public about some of the limitations in AI? So some of the emphasis that we can point out when you're thinking of, one thing I mentioned about the different guidelines and principles that Microsoft came up with for our customers and developers. Don't be mistaken that those were just created for external use. We use it very diligently with all our AI products and innovations and breakthroughs as well. So it's something that we practice internally as well. So to one of the areas that I like to also emphasize is when we're talking about responsible AI principles, for the most part, we have to think of about sensitive use cases. So since AI has a tendency to impact individuals in society, we have to be mindful what impact it has in terms of providing opportunity or discriminating opportunity to certain groups. Another area is what risk is it posing for physical and psychological injury to end users. Then also the threat it could potentially pose to human rights or civil rights. Then, as we know, AI models are a black box. So how can we make it more of, I'll say, opaque or glass box where we're able to communicate? And this is very important. The ability for data scientists or AI developers to be able to communicate to stakeholders exactly how the model is behaving and why. Then also in the debugging process, ask questions like, okay, why did this model make a mistake? That sort of thing. So for data scientists or machine learning professionals out there, you're probably wondering, yeah, we agree that the principles or guidelines are good, but how does this apply to me? Because there's one thing about giving principles and guidelines. At the end of the day, somebody is going to be sitting at their desk training their model, and how do they go about when they're ready to deploy their model, figure out whether or not is responsible. One thing that Microsoft has been diligent about is how can we provide practical toolings to developers to enable them to implement AI solutions end to end using the right tooling to make sure they are touching these sensitive areas. Then also for decision makers, when you have a good AI model, and especially when it has transparency and accountability and reliability, they have more confidence to be able to make well-informed decisions faster for based upon the AI model that they're using. And lastly, the most important people are the end users. How can we gain their trust? How can they find credibility in the AI products that we're producing? So one of the areas that Microsoft has been pioneering in terms of new practices, engineering practices for the data science community is working with the top researchers around the world, institutions, and other developers out there in producing open source tooling. So Microsoft is instrumental in a lot of these open source tooling that enable data scientists or AI developers to be able to utilize these open source tooling, and it gives a holistic solution for them to be able to make sure they are creating responsible AI solutions. So one of the examples are like FairLearn, InterpretML, Error Analysis AI, Econ ML, Counterfactual, and much more. So those are the open source tooling. But as we all know, typically when we're training a model, you have your Python script, you're working in probably in a Jupyter notebook. And if I want to implement, after I create my model, if I want to check for fairness, chances are I'll have to import all these libraries and figure out how to display and visualize it, also interpret the data. So there is a learning curve when it comes to all of this, especially I've only shown you 6 different open source tooling, but what if there are more? So that makes it a little difficult to utilize and maintain. So one of the exciting things that Microsoft has done is to incorporate the responsible AI dashboard in the Azure Machine Learning Studio. So what the dashboard does is basically it is AI interact. I say AI. Well, AI is good too, but it is a UI interactive tool that developers or AI developers or data scientists can easily go in there after they train their model, because it is a you do have your E2E machine learning life cycle that practices that you are working within the workspace studio anyway. So once you train your model, you do have that feature of having that dashboard right there that already has your model and has all these different metrics that you can easily interact with it. And it'll be able to provide insight for you to be able to identify, debug, and mitigate some of the issues with your model. So for data scientists, when it comes to debugging, you have error analysis. And error analysis is basically being able to identify where errors are in your model and where your model is not performing well. You'll be able to pinpoint exactly where that is happening. Data Explorer, that one goes through and checks if there are issues with your data. Is it, do you have an issue with overrepresented or underrepresented data, that sort of thing. And this can potentially skew your model's outcome. Then you have a model overview that gives you a holistic performance metrics about your model. One thing I forgot to mention about error analysis is as you're identifying areas where you have a high error rate, you can also create different cohorts where your model is performing well, and later on be able to do analysis and also compare cohorts. Maybe in one cohort, the model is performing amazing. In another cohort, it's not performing well. So those are areas where you can easily isolate an issue. Another area is fairness assessment. So being able to assess, especially when it comes to sensitive features, is your model potentially violating or does it potentially have fairness issues? Then we have model interpretability. So the good thing is it does provide information about what's driving the model's prediction. So it has explainability and interpretability of your model. And all of this are easy to interact. It provides intuitive information that you can learn and gather insights and be able to act on. Then you have counterfactuals. So after you have your prediction, it could be you're trying to figure out, okay, how can I skew or perturb certain features in my data set in order to sway a prediction. And you can play around with that in the dashboard, and it does a good job of providing insights for you. Then on the business side, it's a good thing to also include business decision makers, where I mentioned the counterfactual what ifs. Businesses can use it as well. But also when it comes to forecasting, making decision like, okay, if we're to introduce this new clinical drug, what would be the impact? So picking a feature and as a treatment and trying to figure out, okay, how is it going to impact the overall data or outcome if we're to impose it. And one thing about this is not really using the model, is actually using your data set. So these are all built upon some of these mature open source responsible AI toolings that I mentioned. So we're almost at halfway mark. So I'm gonna quickly breeze through these section because we're going to see all of this on the dashboard. But one of the first areas of responsible AI dashboard, the first section is error analysis. And one thing I wanted to point out is when we're doing after we train our model to figure out, okay, whether it's good to go, some of the traditional metrics that we're used to is looking at things like accuracy and recall, or looking at the root mean squared error or mean absolute error. So we look at different metrics to confirm whether our model is accurate. But let's say, for example, you have a model that is 90%, has a 93% accuracy. The question is, given these metrics that we have, how are we going to know whether we have data imbalance issues? How are we going to know whether it has fairness or inclusivity issues in there? So these are areas that we have to consider. Also, when it comes to error analysis, similar to how I mentioned, let's say your model came out and said, yay, you have 89% accuracy on overall accuracy. The question is this enough? But the answer is no, because your model, the errors are not uniformly distributed. So it could be areas in your data set where the model is performing 40%, 42% accurate, or another area is only performing 59% accurate. So if you're to deploy this, and for those types of use cases you come across it in real life, that's going to be problematic. Then with the model overview, that area basically, the good thing about identifying where the errors are coming from, the different pockets of errors, and creating cohorts. Now in the model overview section, you can start comparing cohorts and looking for disparities in the accuracy, error rate, precision, recall, or the absolute mean error, and lots of other different matrices that you can explore. So it provides disparity metrics that we talked about, the normal performance metrics. It also gives a probability. So if you have different cohorts, whatever you're trying to predict, out of these subgroups, if you have a subgroup with the highest error rate, you can also look, okay, what is the probability of the model overall even predicting X or Y outcome. Then with the matrix visualization, you can pick and choose what matrix you want to look at. So if you're seeing accuracy, it's like, okay, let me look at recall. Then data analysis, this is, I feel like this is an important part that sometimes gets ignored. But if you have an imbalance of data, this can negatively skew your model. So as we see, we're looking at the age group, and we're trying to figure out, okay, predict whether in a hospital situation whether patients are going to be readmitted or not readmitted. But as you can see, these are 60 or older, 30 to 60, and this is 30 years or younger. There's a huge disparity in the data. The data is overrepresented and whatnot. So when you come into other predictions, since there's an imbalance, they're barely going to have any representation, if any. So that's where some of the data biases start creeping in. So the good thing about the data analysis section, you're able to visualize and explore any fairness or reliability issues, because, hey, you may have a high accuracy, but looking at this, obviously the model is not reliable. So similar to how I mentioned, you're looking for imbalance in data, whether it's overrepresented or underrepresented. Also looking at the quality of the data. Are there any noise in the data? It can expose that. An example of a data set I was using is in hospital situations, looking at how many prescriptions were diagnosed to a patient. So it's between 1 to, I saw the number 1 to 90. That does, like 90 seems pretty high. So you can see where there's like maybe outliers in your data. Feature importance, this is the last section we'll cover. This is actually the explainability part. So it's able to explain for data scientists to understand how the model's behavior for transparency and accuracy, accountability reasons. So they're able to see on the dashboard what are the key features that are driving the model's overall predictions. So you'll be able to see what impact your features have in driving the prediction. Then the good thing about the feature importance is for you as a developer, you can ask questions like, why did my model make this mistake? And how can I improve my model? Or you can ask questions like, how can I understand and trust my model? And for if you're dealing with regulatory situations, you can ask questions like, oh, does my model satisfy legal requirements? Then lastly, one thing I like personally that I like working with the feature importance section is it provides both the global explanation, so all the overall features that are driving your model's prediction, but on a local level, on an individual level, it can provide what's driving, what drove an individual's a model to make an individual prediction. So you can ask questions like, why did patient X get readmitted into the hospital in less than 30 days? Or why did this individual get declined a loan in the bank? So that concludes the introductory part to the responsible AI dashboard. The next section I'm going to cover. Let me know if you guys can see the dashboard. I mean, my browser.
Not yet, Ruth.
Okay.
If you could select it from the show my screen section.
Okay. Oh. Can you see it?
Now we can see it, yes.
Okay, awesome. So do you guys see controls in the way?
We're able to see the cohort all data default.
Okay, perfect. So we're exactly where we need to be. So this is Azure Machine Learning Studio. You created your job. These are your experiments. You registered your model. You go to the model details. It shows you all the different details about your model, your artifacts, and whatnot. One of the tags is responsible AI. So when you click on the responsible AI dashboard, the very first thing that you're going to see is the error analysis section. So this is the tooling. And as you can see, if I click or better yet, hover over the different nodes, the good thing is it does show you the feature condition. So for this node is representing, let me try another node. Is representing if a patient had any prior inpatient hospitalization. So another thing that it does is for each node, it'll show in the data set how many correct or incorrect predictions did the model make. That's number one. The next thing is it shows the error rate. So the error rate is just a percentage between the number of correct and incorrect. So the higher the error rate, the more you know there's a problem. And the coverage is basically for the errors that are happening in this particular node or this condition, how much of it is coming from the total errors. So let's take a step back. The root node gives you information such as the total number of records. These are the total number of data sets you had in your test data. Out of that, these were how many that were correct, 169, and 826 were the ones that were correct. So you can traverse in the node and kind of have a feel of what those features are. But as a visual aid, what the dashboard does to help the users is the nodes with the highest error rates are actually color coded. So the darker the red, the higher the error rate. So you can, if I want to investigate this cohort that has, it looks like this is the darkest path, I can double click on that, on the root node. It will highlight all the parent nodes, and easily I can click on save as a cohort to give it a unique name that describes that cohort and be like, okay, I want to save that and investigate it later. You can create as many cohorts. Another thing personally I also do is I'll also look at the best performing, the path with the least error rates, and I'll also click on that and save it in order to figure out, okay, why is the model performing very well in this cohort versus another? So that's one thing that the error analysis does for you. The whole point is for you to identify where the errors are coming from and be able to investigate. Another cheat sheet, I call it a cheat sheet that I like, is the fact that it provides a feature list. So on top of all of these features, it also shows the different features that are driving this model's errors. So if you notice, age is on top of the list. So as you go down, these are the top features, and these are used to create the error, the tree map, depending on how you control the depth of the tree. it will expand or shrink the tree to show more features. Another part is the heat map. And the heat map is another way of picking a particular feature. So let's say I saw age, and age is saying it has like the highest error rate. And I'm like, okay, why would age have a higher error rate? And I select the age. You can select one or more combination of cohorts. And if you notice, the dashboard has the intelligence of going into your data and be able to select it into meaningful different groups. So if I hover over the age 60 or above, I noticed that it has a 18.79% error rate, which is pretty low, but the error coverage, like the number of errors coming from this cohort, is pretty high. Another area, let's say another area is age 30 to 60. You can either click on it or double hover over it, and it'll show you the error rates and also the coverage. And that's how you figure out, okay, is this something that I need to be worried about? So if I want to look more into this cohort that has a very high error coverage, because it shows like almost 74% of the errors are coming from this feature, I can easily save it there for other analysis. And once you create all your different cohorts, you have a way of managing the ones that you've created. But by default, the dashboard will create a cohort with all the data. Okay, let me see how we're doing on time. Okay, I'll try and go through this in the next 5 minutes to give you guys a chance to ask questions. The next field is section is the model overview. So looking at the different cohorts that I created, this is already system generated. This was the cohort that has the most errors. And we see the data set, the sample size for that data is 143. And the ones with the least errors is this one. And sure enough, when we look at the accuracy, we see that the one with the highest error rate, where the model is performing worse, it has a 65% or 66% accuracy score. Then when we look at things like false positive, we notice a false positive that's low, but it seems like the false negative is extremely high. So that's also something to take into account. So as you can see, this is how you can look through and do comparative analysis to figure out, okay, what's going on with this data set. Another thing you can also do is under probability, the cohorts that you created, you can look, in this case, we're dealing with patient data, diabetes patient data, and we're trying to predict the probability of them being readmitted back to the hospital in 30 days or less. So if they're not readmitted, that means in 30 days they were not readmitted. So it shows that the cohort in general overall, it seems like most of the data, the patients are not going to be readmitted. Another thing you can do is also flip it around and check whether, okay, how about the opposite? What are the probability of for these cohorts for patients in these cohorts to be readmitted. So obviously the ones with the higher error rates show a higher probability. So these are ways that you can play around with the dashboard. One thing that I was mentioning is for the metric visualization, it did show the accuracy up there, but everything that is showing right now is pretty much what we saw. But one of the good things is you can select something like, okay, let's look at the precision since this is a classification use case. And it looks like even though the accuracy was 83, it looks like the precision has gone down, but the cohort that was performing better, it seems like the precision is still high, even though the others have gone down. Then when we look at recall and see what happens to recall, the recall goes completely down the tubes. So we realize that there's a problem. Another thing it does is also provide the confusion matrix. So you'll be able to visualize what's going on with prediction. So you can look at the false positives and the false no, the true positives and the false positives and whatnot. The one thing that we notice is automatically you can see that when the model is trying to predict the non-readmitted, it seems like it's doing well. But for the use case where it's trying to predict the patients that would be readmitted, is not doing so well. So either there's a imbalance, data imbalance issue, because there's a drastic change in the data set, difference in the data set, or the model is not learning too well. So those are things that you can look at. Then another area that I wanted to also show you is the model overview also gives you the ability to choose individual features, and automatically, like I told you, it will intelligently divide it into sub cohorts that make sense. And you can see for this feature how many patients fall in this feature. So almost a majority of the patients in the past had less than 3 inpatient hospitalization. You can look at the accuracy. You can look at the areas, the use case where they're struggling. So going back, and you can also come down and look at the same thing that we looked at, the probability and distribution, the metric visualization, and the confusion matrix. You can do all that comparison. But one thing I wanted to point out is this is very good because when you're creating your cohort, it may have a lot of features in there. So a good way to isolate and see where a problem is coming from is going to the feature cohort. It could be we can look at the number of meds a patient is also taking. If everything looks good, it has high accuracies and whatnot, then we know that's not a culprit of the problem. The next area is basically the error analysis. And with the error analysis, it shows you a table of the correct predictions and incorrect predictions on the individual basic. But the good thing you can also do is be able to plot and explore the data that you have to see, to better understand. So for me, I want to see, okay, what is the true overall distribution of my data? So I'm seeing that 811 patients fall in the not readmitted use case, and 183 fall in the not readmitted use case. Let me change this to see what the model is actually predicting. And as you can tell, the model is not predicting, not doing well when it comes to prediction. So we're starting to see issues there. Another thing we can do is maybe look at things like the actual data set. So let's look at the race distribution. So if I look at the race distribution, you can see there's also a disparity. There's more Caucasian patients than the next group is African American. Asians are not represented, and Hispanic. So this automatically tells me that there's an imbalance. And let's say you take your model, let's say the data was gathered in a predominantly demographic where they're more Caucasian, and you're trying to run the same model in another community, maybe a Hispanic community. This would not be a reliable model. The next thing we can also look at is gender. Okay, how is gender behaving? And gender seems fairly balanced, so we don't need to worry about that. Then another thing we can also do is look at predictions. Let's say for race, for age, how is the model predicting when it comes to age? We're also seeing a huge disparity. So these are examples of how you can look at your data and see how, whether there are imbalances and potential issues. And the good thing is you can also switch cohorts. So if I want to look at all the data or see how this is behaving in, like, I'll select another cohort. Let's see, for the worst performing cohort, how does this look like? You can see still how the data is behaving. So it's good to have the data, analyze the data with all the data set, but also put it in different environments and see how the data is performing. So that's about the error analysis. It has a lot of different tools or matrix that you can select on. Let me try and cover the next section in 1 minute. So the next is feature importance. So you have an aggregated view, and the good thing about the feature importance is the orange shows all the data. The different cohorts that you created has the color code, different colors. But as we can see in our data set, it looks like prior inpatient hospitalization, age, number of diagnoses, whether a patient had a prior emergency situation. Those are the top 4 features driving whether or not a patient will be readmitted back to the hospital. And as you scroll down, you can see the rest of your data. The rest of, features that you use in your data set, and see what role they are playing in impacting the model's decision. Another cool thing you can do is, let's look at the number of, let's say, medications. Actually, let's see, number of diagnoses. So you can pick a particular feature, and let's see what the number of diagnoses besides diabetes that if a patient has, what impact do all the different values have whether or not somebody is going to be readmitted. So it shows that between 1 and the threshold is 0 up to 7 on diagnosis. The model is going to positively, these values positively influence this prediction that yes, they are going to be not readmitted. But once the number of diagnoses falls below 0, it's negatively impacting this prediction. So that's how you can also see how feature values impact positive or negatively impact a model's what's it called, prediction. You can also go to data. So let's say we're doing patient auditing, and for this particular patient, the model got incorrect prediction. So what the data scientists can do is go down and drill down and see, okay, for this patient, what were the features that were positively driving the prediction? They're selected, hang on. Okay, they were predicted as not readmitted. That's, yeah, predicted why. They were predicted as not readmitted. So why did the model get it wrong? So it shows that age positively influenced that wrong prediction, and also how they paid Medicare. So their social economic standing also positively skewed the model to make that prediction. The ones that negatively would have helped the prediction to be readmitted are the ones below 0. So these are ways that you can play around with the data. We don't have time to go into details about counterfactuals, but basically, whatever your data set is, you can select it, and it shows all the predictions that the model made, but it also shows different opposite alternative suggestions that if you change if you change this patient's record, it'll change the model's outcome to be, I think one is not readmitted. So 0, if you want to change it to 0, is saying that the max glucose serum needs to be updated to that value. And if you also notice, this is another good way, even though it's showing you how you can perturb certain features to drive a prediction, it's also a good way to debug your model to see how fair it is, because telling a patient that in order for you not to be readmitted, you have to change your race to Hispanic, that's a flag that we need to go back and debug the model further. So that concludes this presentation.